Hello, this is the team Big Data and the Big Dream. Our team topic is the prediction of city bike share in NYC. This is our agenda. Introduction. We all know that in city bike system, there's no efficiency in the city bike usage, and the distribution of each bike station is very terrible. Some customer complain about that in some high population flow area, there's no bag to use, and in some low population flow area, there's many free bags. So we also want to test the different trips between holidays and workday. For goals, we want to predict the daily trip counts based on the holidays and business days through some algorithm. And we also want to predict the optimized distribution to get the best solution to distribute each bag station. The tools we used, first one is Panda. We use Pandas to load the data and manage the data frame. And the second one is the base map. This is the map API we use to locate each station position according to their coordinates. We use Seaborn to plot the histogram of the data we processed. And the sklearner is a package of many machine learning algorithms. So right now, let me show you the data and the code. So we load the data through the Jupyter platform. We import each tools like Seaborn and the Pandas. So talking about the data we found is from the CityBag official website. It's very huge, like 3 GB. So we spend a lot of time to load the data and do some modification on the format of this data. You can see how we load the data.
We first do some analysis on our data set. We do sort them by the longest usage duration of start station and end station, and also the most usage times of start station and end station. And this is the code. This is the code. We do it first. We sort them by the total duration seconds by the descending order, from high to low, and this is our consequence. You see the 2006 this start station has the most total duration seconds, and then we do it by the count. That is the usage times. This is also descending order, and then we plot it. You see the longest usage duration of start station. This is the same. It's the same in the slides. We got many dots of distribution, and the most usage times of start station. This is a bar chart, and then we do the same thing in the ascending order. You see this the 3385 start station has the least total duration seconds, and then we do the same thing about the count. The save station, it only has one count in the 2016. And this is the shortest usage duration of start station, the graph, and you see that not only dots, we also have some bars. It's like a castle, yeah. And then we do the same thing about by the least usage times of start station, and then we also do it by the end station. You see, this is the graph of consequence of end station. Yeah, this is it. And then we do the visualization by the base map API. Actually, we locate every station by longitude and latitude on the map of Manhattan, and you see we have some scales like 100 million and 400 million, 1 million, 4 million, 7 million, and 10 million, 50 million. And then we combined 12 graphs together. We got that. You see, this is the GIF, and in January and February, November, December, the most used times, the most used stations has less than 7 million used seconds, and in July, the most used station has less than 25 million seconds. As we can see that when it's getting colder, less people choose to travel by city bike, and in July it is the summer break, and many tourists come to New York, and they might choose to travel by city bike.
So after we do the statistics analyze, we do some prediction based on the machine learning. First, we should add features to our data. Now we use two features: is whether it is a business day or whether it's a holiday, and the label is also what we want to predict it is the total trips of one day. So we first sum up all the trips of one day and add the features. So you can see in the red picture that this is the data frame of our data set. And so the algorithms we use is this 5 algorithms. They are both they are all popular algorithms. Actually, we do the machine learning separately based on each algorithm. And we write a score function to evaluate all this algorithm, whether it's good or whether it's bad. So I can show you the code. Yeah, like you can see that here, we do machine learning based on all this algorithm, and the score, you can see the score of GBR, which is gradient boosting, is 6,000, but actually for IFR is less than 6,000. So we base on these scores to find out the GBR and a DTR has the best results. So we combine these two algorithms to get the best results of our prediction. So you can see the arrow is very small based on all this algorithm. So this is the results that we got. You can see the tendency and the prediction value is very similar to the actual data. So this is all what we have got. And for the future, I think maybe we can try some real-time traffic streaming data, and also we can give more considerate conditions such like economics, and also we can do more about the distribution of the city bike station in NYC. So this is reference, and thank you for listening.